Well, the question says create a variable my age and store your age in it. Subtract 1 from the value of the variable, add 2 to the value of the variable. Let's say my variable is my age. Okay? And then I store in the value 20. Let's say my age is 20, and then I store in the value 20 in the variable my age. Now, let's say if I say my age minus 1, and then I can see obviously Matlab will do the value of my age minus 1, which is 19. But if I press in my age, the value of my age didn't change. Okay, you can see it's still 20 as it was initialized. And then if I do my age plus 2 and then press enter, I can see 22, but when I type in my age and then my age is still 20. Okay. Why? Just because the variable my age was initialized to 20. To change in the value of the variable, as the question implies, like when it says subtract 1 from the value of the variable, it means we must do my age equal to my age minus 1, and then press enter. Now, when you type in my age, you can see that my age is now 19. Okay. Similarly, if I can press the up arrow button to go to the previous command line, and then I can put plus 2 and then press enter, my age now is 21. You see, if I say my age now, my age is 21. Okay, the reason is now we change the value of the variable. You can also notice previously when I initialize the value of my age equal to 20, and then I say my age minus 1 equal what? Matlab didn't say my age is equal to 19. Matlab says ans, the default variable ans, okay, is equal to 19. Same also here, when I did my age plus 2, the default variable ans appears again, and then say that that ans, standing for answer, is equal to 22. Yes, because the value of the variable were not changed, and it kept its original value as initialized by 20. Now, here then, when I say my age equal to my age minus 1, you can see that Matlab responds by saying my age now equal to 19. Same also here, my age equal to my age plus 2. Matlab responds by saying my age is equal to 21. Thank you. Well, the question says, use the built-in function nameLengthMax to find out the maximum number of characters that you can have in an identifier name under your version of Matlab. Alright. Well, there is a limit to the length of the variable name. The built-in function nameLengthMax tells how many characters this must have. So if I go, let's say nameLength max and then press enter, in this Matlab version, the maximum name characters that a variable name must have is 63. Okay, let's check. Let's say my variable is n 1 2 3 4 5 6 7 8 9. Okay, that's 10 characters, right? And then I say this is equal to 4, for instance, and I press enter. This is accepted in Matlab. Now, what if I did something like, I want to test this. If I do something like n 1 2 3 4 5 6 7 8 9, it's 10 character now, 20 character, 30 character, 40, 50, and 60 characters. And then let's test this is equal to 4 and then press enter. This is still accepted because it's too long, but it's still accepted and by Matlab. Now let's see if I wanna do more characters. Let's say I'm gonna add the character A, B, C. So 60, let's say 61, 62, 63, and then this still accepted if I press 4, and then wow. Yes, now if I want to do more characters, I want to see if I can break Matlab. I'm going to add the 64th character, let's say D, equal to 4. And then Matlab respond with a warning. And then disregards the 64th characters. You can check here. D is ignored. Okay. Yeah. Thank you. Well, the question says explore the format command in more detail. Use help formats to find options. Uh, Experiment with format bank to display dollar values. And yeah, well, you can use Matlab to learn about Matlab. If you need to learn about any command, just press in help and then followed by the command name. Let's say now I want to learn about the format. I want to explore more about the format. So I press help format and then enter, and it gives me this gives me information. This is information about formats. Now you can see where format long, which is the default format, and then the long format, format short, long, etc. I can see format long, format shorten. This is for engineering formats, and I can see there are a lot of formats. The hexadecimal format. Uh, Voila, I can see the format bank here, format prat, but what I did is this one. I highlighted format bank, that fixed format for dollars and cents. Now to clear all this, I can just press in CLC and press enter. That's all cleared. I'm gonna write here format bank. Format bank round up to the second decimal place. So if, for instance, I say let's say 4.789, and then press enter, this will round it automatically. This is like $4 or 4 rand 79 cents, and so on. If I say something like 0.51, this will be 0.51, which is 51 cents. But if I do 0.57 and you round up, oh yeah, still 0.57, but if I do 0.578, for instance, this will be rounded to 0.58. Thank you. Well, the question says find the format option that would result the following output formats 5 over 16. Okay, after that, we explore the formats uh, uh, by using the help function. Let's say help format and then press enter. You see there's a format called format rat. This format, we will be using the format rat. It says approximation by ratio of decimal integer. Numbers with a large numerator or large denominator are replaced by stars or dots. Okay, fine. Let's use this one. If I do, I'm gonna clear here. Say I can use the CLC to clear the command window. I can see if I wanna write 5 over 16, I'll write format rat, enter, and then I can say 5 over 16. Press enter. Now I have it. If I want to do 2 over 7, then I can write 2 over 7. So if I want to do this addition, 5 over 16 plus 2 over 7, this will give the result 67 over 112. Thank you. Well, this question says think of what the result would be for the following expressions and then tap them to verify your answer. Alright, Now let's see. Let's think about the results. When we see 25 over 4 times 4 like this is the same as 25 over 4. It can be written like this, times 4. And then when you see an integer 4, it means all integers have a denominator of 1. So this we can simplify. Okay, 4 times 4, remember? And this is just equal to 25. Okay, we can test it in the Matlab. When you do 25 over 4, okay, 25 over 4 times 4, and then press enter, and the solution is 25. Okay, similarly, the next question is let's say 3 plus 4. This symbol, the carré symbol, stands for exponents in Matlab, so this is the same as 3 plus 4 times 2, 4 to the power of 2, is 16, and then 3 plus 16, that's 19. We can test it in Matlab. We do 3 plus 4 carré 2, and then press enter, and this displays the result of 19. Okay. Now let's see the other one. 4 over 12 plus 4. Okay, this one you don't read 4 over 12, rather 12 you read it backwards. 12 divided by 4. This can be written as 12 over 4 plus 4, and then you do 12 over 4, which is 3. 3 plus 4 is 7. And then 5 minus 2. Okay, in the bracket times 3. We come into this. Let's first see what if this is equal to 7. Now we're going to do 4 slash 12 plus 4, and then press enter, which is well, I used the wrong symbol. Say 4 slash like this 12, and then plus 4. Yes, this is what's supposed to type, and then press equal, and then enter. We have 7. Correct. Now what about this one? 5 minus 2 in the bracket times 3. This we work out the bracket first. 5 minus 3 is 3, and then 3 times 3 is just 9. Okay, and let's check this in Matlab. That would be 5 minus 3 times 3, and then press equal, enter, and then this, oops, yeah, that makes 2. Yeah, just because here I did it, I meant here it's supposed to be 2. So 5 minus 2. Yeah, 5 minus 2. Yeah, 5 minus 2 is 3. Sorry, 5 minus 2 is 3, of course. And it's there, say 5 minus 2. Supposed to say 5 minus 2. So now to correct this, I'm just gonna press the arrow button, the up arrow button, and then I'm back there. I can correct this. 5 minus 2, yes, times 3, and this is equal to 9. Well, thank you. Well, the question says, create a variable pounds to store a weight in pounds, convert this to kilograms, and assign the result to the variable kilo. The conversion factor is 1 kilogram equal to 2.2 pounds. Alright, this is what we've given. What the conversion rate. 1 kilo is equal to 2.2 pounds. Okay. This simply means we can assign in values to the variable pounds. Pounds can get values, and then You can get values like you can get value of 10. If this is 10, we're going to do 2.2 times 10, and then we find the kilo is going to be 22 kilo. So if this is like 20, and then this is going to be 44, and so on and so forth. So we're going to write kilo. In Matlab, we're going to write kilo equal to 2.2 pounds. First, we're going to declare the variable. Now, first, we need to create a variable. Let's say the variable pounds. I'm going to create variable pounds, and then store in values. Let's say 20. I store in the value 20 pounds, and I press the semicolon because I don't want Matlab to tell me again what the result, what's the value of pounds is. I know it's 20. So now, okay, I create the variable pounds. Then I will write the very formula I used there. I'm going to say okay, kilo equal to space equal to 2.2, and then I'm going to say okay, I'm going to say pounds like that, right? No, Matlab will say send error. I need to put there the multiplication symbol, the star symbol stand for multiplication. Then if I do, then if I press enter, well, I have an error message here because undefined function pounds or variable pounds. Just because I wrote pounds, here I write pounds. Now Matlab suggested if I mean this, yes, this is what I mean. This is what I do. Then I just press enter. Voila, I have the results. I can do if I change. I initialize pounds to let's say 15, and then I press enter, and then I find I want to know how much that's in kilo. Use the upper arrow button and then press enter. Voila, it tells me how much it is in kilo. Okay, thank you. Well, the question says the combined resistor RT of three resistors R1, R2, and R3 in parallel is given by RT is equal to this expression 1 over R1 plus 1 over R2 plus R1 over R3. And then the question says create a variable for the three resistor and store values in each, and then calculate the combined resistors. Alright, we're going to do, let's say R1 equal to 1. For instance, R2, I prefer to say R2 equal to 2. And then R3 equal to 3. Okay. Now I have all the three resistors. Now, to combine them all together, I can just say RT equal to 1 over, and I use brackets like this. And then I go 1 over R1 plus 1 1 over R2, 1 over R3, and then press enter. Voila, I have the results. The same thing can be written if I did if I do open brackets. You can use the up arrow button if you need to go back to the previous lines. I can put brackets here in each of the resistor, like 1 over R3 brackets here for this, and then bracket also because we do the all under one. Okay, I have one, I open brackets for all the resistors, the sum here at the denominator, and then if I press enter, still have the same result. Thank you. Well, the question says create a variable F temp to store a temperature in degrees Fahrenheit F, and convert this to degrees Celsius, and store the result in a variable C temp The conversion factor is C equal to open bracket f minus 32 close bracket times 5 over 9. Alright, so the variable f temp, I want to store a value there, let's say 100 degrees. Okay, and then I'm gonna create a variable now c c temp, and then say okay, use the formula for the degree for the conversions as mentioned above, but I'm gonna use, instead of c, I'm gonna write c temp open bracket f temp minus 32 just put space there times 5 over 9, and then when we press enter we have the degree converted into Celsius. 100 degrees Fahrenheit is equivalent to 37.7778 degrees Celsius. Thank you. Well, the question says the function sine calculates and returns the sine of an angle in radians. Use help elfan to find the name of the function that returns the sine of an angle in degrees. Verify that calling this function and passing 90 degrees to its results results in 1. Okay, let's see. If I do sine of 90 here and then press enter, I don't have 1. That's 0.8940. Okay, perhaps they rounded up. Perhaps this is the initial value and then the 1 is just the rounding value. I don't, let's double check. We do know that sine of 30 degrees is equal to a half. But if you press enter, I have something different. Okay, this is because this function sine doesn't get in the angle in degrees, rather in radians. So this text here, it takes 90 radians, and that 30 also in radians, the angle in radians. So now, if I need to take the angle in degrees, I need to change the function. What can help me is to use okay, let's first clear the command window. I'm gonna say okay, I can just say clear and then CLC, so I clear both the workspace and the command window at once. And then I'm going to do help elfan for elementary function, and then press enter. This will display the functions, elementary function in categories. We have the trigonometric functions here, and then exponential functions, complex function, rounding functions, etc. And rounding functions. Alright, now we're talking about angles and sine. This can only be in this section. We can see that the first one is sine, and then the second one sine d, sine of argument in degrees. Oh, this is the function we are supposed to use. So now I'm going to use sine d instead. I'm going to say sine. Okay, let's just clear this. CSC. I'm going to say sine d, and then this will take the angle in degrees. This is 90 is in degrees now, and then press enter. We have 1. I can check it out, sine of 30, and then I have a half. Oh, I say sine, but I meant sine d. Sine d, I have 0.5, which is a half. I can try what else? Yeah, sine d of 180, which is just 0, and voila, we have it. Thank you. Well, the question says a vector can be represented by its rectangular coordinates x and y or by its polar coordinates r and theta. The relationship between them is given by the equation x is equal to r times cos theta, y equal to r times sine theta. Now we are requested to assign values for the polar coordinates to variables r and theta. Then using these values assigned to the corresponding rectangular coordinates to variables x and y. Alright, let's say r equal to, let's say 5, and I'm gonna put the semicolon to do not repeat the answer, and then let's say theta equal to let's say 30 degrees, okay, and then we can write the conversion to polar coordinates. It r times x is equal to r times cos, am I gonna say cos theta? Not exactly. I must do cos d because the angle is given into degrees. Then I can press semicolon and then say y equal to r times sine theta, for instance, sine d theta, and then can put the semicolon. So when I press x, for instance, enter, and then have the value of the angle, I mean the coordinates of x in x expressed in polar coordinates. Similarly for y also, I have y in polar coordinates. Thank you. Well, the question says a vector can be represented by its rectangular coordinates x and y, or by its polar coordinates r and theta. The relationship between them is given by the equations x is equal to r times cos theta, y equal to r times sin theta. Assign values for the polar coordinates to the variables r and theta, then using these values assign to the corresponding rectangular coordinates to variables x and y. Alright, now let's say r equal to 5 units, and then I'm going to put the semicolon to avoid Matlab to repeat the same answer, and then I'm going to say theta equal to 30 degrees, for instance, and then put semicolon, and then I'm going to say, okay, let's say x is equal to cos theta, right? Not exactly, because the angle must be in degrees. I'm going to say cos d, and then similarly let's say y equal to r times, oops, whatever, that cos was not so well, I didn't write it well, so I'll put the upper, I'm gonna press the upper arrow button to correct it. Let me correct it. Where is it? I didn't write the right thing there. Okay, it's supposed to be, okay, let's put the upper arrow button. Cos, yeah, it's supposed to be r times cos theta. Yeah, r times cos d theta, correct, that's the right thing now. And then y will be r times sine d theta, and then press semicolon, and if I press, for instance, x and then enter, I have the solution there, y, and then enter, also the solution. Thank you. Well, the question says wind often makes the air feel even colder, and it is. The wind chill factor WCF measures how cold it feels with a given air temperature T in degrees Fahrenheit and wind speed V in miles per hour. One formula for the WCF is given, and then create variables for the temperature, for the wind speed, and then using these formulas to calculate the WCF. All right. We do have two variables here, the temperature and the temperature T and V. Okay, let's say T equal to the temperature in degree Fahrenheit. I'm gonna say 77 for instance, and then the speed. I'm gonna say just random numbers, like let's say 50, and then the formula is given by I'm gonna say now let's say WCF equal to 35.7 plus 0.6 times T, 0.60, like that. Nope, I must put the star times T, and minus 35.7 times, open and close bracket, that's V node, but we just want to use V because yeah, it's gonna be oh, it's actually V 0.16 V. So V times 0.16 plus 0.43 times T times V times 0.16, and then we press enter. We have the WCF, which is the windshield factor. Thank you. Well, the question says use help Elfan or experiment to answer the following questions. Okay, I'm gonna do help Elfan and then press enter. It will list the categories of elementary functions. We have trigonometries, exponential, and here we're interested in this section, rounding and remainder. So now let's see what's about fixed function. Fix 3.5, it's 3, and then what about flow 3.5? If we do flow 3.5 and those equal to 3, so these two are equal. What about fix 3.4, 3.4, and fix negative 3.4. Okay, that makes negative 3. What about fix negative 3.2 and flow 3.2? They're equal. What about fix negative 3.2 and sail negative 3.2? They're also equal. Thank you. Well, the question says find Matlab expressions for the following. What about square root of 19? So the function is the sqrt, Okay, so if you see sqrt 19, same as for many programming languages, and this is actually the square root of 19, 4.3589, and 3 to the power of 1.2, we do 3, and then we use the carry symbol to write the exponent, so exponent to the power of 1.2, and then 10 of pi, we're going to do 10 if we want you're gonna say 10 pi, like this in radian, or 10 d pi, that's in degrees if pi is a degree, but actually pi is radian. So this is how it is. Thanks. Well, the question says use int min and int max to determine the range of the values that can be stored in the type int32. Alright, the, the range is the difference between the maximum and the minimum. So I would say, okay, I prefer to just give a variable range and then say range int max minus int min, and then press enter. It tells me that the range is this number is actually a bit. I struggle to read numbers like that. I just say 214783647. Yeah, you know if it's billions or million. Thank you. Well, the question says generate a random of real number in the range from 0 to 1. We know that the function range uh, generate random numbers in the range of from 0 to 1. And when the question says a real number in the range from 0 to 20, then we're going to do rand times 20. Okay, and this will generate real numbers between 0 and 20. See that range. Now, the following question says real numbers in the range from 20 to 50. In this case, we're going to do 20 as our lowest interval, plus we do rand times the difference between 50 and 20, and then this will generate numbers between 20 and 50. So we go, that makes 24, you see, it's gonna be only between numbers between real numbers between 20 and 50. All right, now let's see integers in the range from 0 to 10. We can just say we can okay, normally we can do the range times 10, but now we're going to round the function, round this expression, I mean, and then when you press enter, then this can generate numbers in this interval between 0 and 10. Okay, from 0 to 10, and then integers in the range from 0 to 11. It's similar like the previous. We're just going to do times 11 here, and then it will give us, it will generate integers between 0 and 11. You see, the highest number is 11 there, and yeah. Okay, now integers in the range from 50 to 100, we can just do 50 as our lowest interval, and then we do rand times the difference between 100, the highest and the minimum, so 100 and 50. But now all this must be in the round function because we need to round this. We can run this. Then, when we press enter, it will generate numbers between 50 and 100, as you can see. Thank you. Well, the question says, in the ASCII character encoding, the letters of the alphabet are in order. Lowercase a comes before lowercase b, and uppercase a comes before uppercase b, for example. However, which comes first, lower or uppercase letters? Okay, let's first check this out. We're going to do that by using the lesser than symbol, that angle, they call it angle bracket sometimes. Okay, if I do, let's check this out. If I do lowercase a and then do lesser than lowercase b, and then I press enter, and then I have the logical answer, which is 1 stand for true. And let's first reverse the order. Okay, I don't need this. If I want to reverse the order, I can just say b lesser than a, and then press enter. 0 stand for untrue, which is false. And let's check also for the uppercase. If I do uppercase a lesser than uppercase b for the to check if this is true, and then press enter. Yes, it is true. Uppercase a comes before uppercase b, and then let's reverse the order and see what happened. B uppercase b lesser than uppercase a, and we have 0, which is false and true. Now we're going to check if the uppercase a comes before the okay, let's say the lowercase a comes before the uppercase a. Let's check this out. We have 0, which is untrue. I'm gonna reverse the order. Let's say uppercase a lesser than lowercase a, and then press enter. It's true. Okay, but now let's see the last letter of the alphabet, Z, and then see, compare if Z, uppercase Z, will be lesser than lowercase a. Yes, this is true. So we can conclude by saying in the ASCII character encoding, letters, uppercase letters comes before the lowercase letters. Thank you. Well, the question says, using the colon operator, create the following vectors. Okay, we can use colon operator to create vectors. I can say this is what I call formulas. I call it formulas. We can use this one, x1 colon operator to xn. This will generate a vector with element that increase by 1. Okay, like in this case we have the vector 3, 4, 5, 6. You can see that the element increased by 1. So we can create this vector by saying I'm going to say 3 colon operator 6, and then press enter. This generates a unit space vector. Okay, all elements increase by 1. Now we can also use the other I call it formula, this one. This creates a pattern, okay, of generate a vector with element following certain pattern. Like in the example, in this example we have like 1.0000, 1.5000, 2.0000, 2.5000, and then 3.0000. We can notice that elements here follow certain pattern of 0.5000, actually 0.5. Okay, it's a constant difference. Okay, it's increasing by the constant difference of 0.005, 0.500. So it is 0.5000. Okay, now we can call this constant difference D. Okay, let's say this is D, the constant difference, and then this the initial value, so our x1, and that's the last value xn, and that's the constant difference. So we can write generate this vector by doing something like, let's say 1 column operator 0.5 column operator and 3, and we press enter. So we have this vector 1 1.5 and then. Okay, and the last question is we need to create this vector 5 4 3 2. We can say that this is decreasing by 1, so we're going to do 5 column operator -1, because we add -1 to each element, and then the last element, and then press enter. We have the required vector. Thank you. Well, the question says, using the line space function, create the following vectors. All right. The line space function generates linearly spaced vectors. Okay. And the formula is, according to the formula, line space open bracket x1, comma, x1 stands for the initial element, and then comma x n standing for the final elements, comma the uppercase n stands for the number of elements. Okay, so we will do line space. Just note there is no e in between n and s, so line space 4 for the initial elements, and then we can see that the last element here is um, 8, so we go 8, and then how many elements? 3, so we press enter. We have the required vectors. Similarly, we can do line space open brackets x1, the initial value, which is -3, and the last value is -15, and how many are them? There are 5, so I press 5, press enter. We got the vector. And similarly, we can also go line space open brackets. We have the first element is 9 and the last element is 5, and then there are 3. When we press enter, we have the required vectors. Thank you. Well, the question says create the following vectors twice using line space and using the column operator. Okay, if I want to use the line space, I'll go line space vector, which is okay, I'll say 1 to the initial element is 1 and the last element is 10, and then there are 10 of them, and I press enter. I have the vector. Okay, so if I want to use the column operator, I can just do 1 column and 10, and then press enter and the vector. Now if for the other vector 2 7 12, using the line space vector, I'll go line space, oops, there's no e between the n and s, line space I'll go 2, and then for the initial number, and the final number is 12, and then how many of them? There are 3. First 3, and then enter. Voila, we have it. So if I want to use the column operator, I'll see the pattern from 2 to 7. Okay, I'll go like, I'll follow this pattern. You can see we have two 7 and 12. The difference here is of negative of 5, so the positive 5, so plus 5. Then I will write 2 to 5 to 12. So that would be 2 a column operator 5, column operator 12, and then press enter. Voila, I have the vectors. Thank you. The question says, create a variable, my end, which stores a random integer in the range from 8 to 12. You seek the colon operator, create a vector that iterates from 1 to my end in steps of 3. Alright, let's say we need to create the vector. First of all, the variable my end, okay, and which stores random integer. Random integer will be given by this, I call it formula. It's gonna be randy, random integer, randy, and then if you put a square bracket here, not a square bracket but a round bracket, we put round bracket here, one there and one there, and then in the round bracket we text the x min, I call it x min, and then there will be x max. I think I still need some space. Let's do this, x max, close bracket, and then there I can specify the row and column. This is how I can do that. So here I will be doing I'll say my end. That will be randy, open brackets, and then square brackets, and then I will say the lowest number here is 8, and then the highest is 12, and then because I just want a number, not a vector or a matrix, I just want to stop by, I want to say, okay, only one column and one row, because this really reproduce a scalar. And if we press enter, we see that we have a value 12. This we can test it. Let's see, 11, 12, 11, 8. So it can only reproduce numbers in between from 8 to 12. Okay, not more or not less than that. Okay, I'm gonna clear this by using the CLC command, clear command window. So now I'm gonna write it again. It was that. Okay, I'm gonna put a semicolon because we tested this already. Now let's now use the colon operator to create a vector that iterates from 1 to my end in steps of 3. Okay, do I need to name a vector? It's not mentioned, but I can just go say 1, 2, step of 3, and 2, my end, and when you press enter, we have this. Okay, before to see that, we need to go back to see how much is my, okay, I'm gonna remove the semicolon because I want to know the highest number that my ends must is, and then I can use that column operator. You see, my end was 9, so in steps of 3, that's why it takes 1, 4, and 7. Okay, and if I do it again, I say this one, my end is 8, so this also in steps of 3, it will give me 1, 4, 7. Again, if we go, that's my end is 8 and my end is 12. This time, if I go, I need to find that vector following the column operator in steps of 3. It gives me 1, 4, 7, 10. Thank you. Well, the question says create a variable myEnd which stores a random integer in the range from 8 to 12. Using the colon operator, create a vector that iterates from 1 to myEnd in steps of 3. Okay, the same question has been done previously. We used the randy function, but this time I have something newer. I want to use the rand function. I want to do it differently. Okay, we all know that the rand function generates uh, real numbers in between 0 and 1. So if you can test it. So if we type rand on the command window, it will give us numbers between 0 and 1. Okay, now that we do know. If now I want to have to generate numbers starting from 8, I can just do 8 plus rand, right? This will never give me a number lesser than 8, as the intention is to have a number that starts from 8 uh, and uh, and stop by 12. Okay, so now we can see that it just gives me a number between 8 from 8, the integer is 8 and then comes decimal parts. It doesn't reach 9, not 10, or like it doesn't reach 9. So if I want that it generate numbers up to 9, 10, 11 and decimals, I can just do this. Let me clear all this by CLC. I'll say okay, I say 8 plus 10. I will times this by the difference between 12 and 8. I'll do 12 minus 8. And then press enter. You see, now it generates numbers between 8 and 12. But I have decimals. So if I don't want those decimal parts, I want to generate only integers. I can now, okay, let me clear this. I can now I should press the upper arrow button to go to the previous command line. I can now just add the round function, because the round function round to the nearest integer. So if I do round function in front of this, then it's not necessary for me to do this. Okay, I could do that, but I could do this. It's still gonna work. Okay, it's still gonna work if I do that, but I don't see that the point. I can just go do place my round function here, because 8 is an integer, so it doesn't need to be rounded at all. So if I do that, this will generate random integers between 8 and 12. You see, as you can see, it will generate those numbers between 8 and 12. Correct. Thank you. Well, the question says using the colon operator and the transpose operator, create a colon vector that has the value -1 to 1 in steps of 0.2. So I will go, I'll say, okay, -1 and steps of 0.2, and then to 1. And then to transpose the operator, I'm going to put everything in the bracket, and then I can use the apostrophe symbol. This transpose the vectors into, okay, without the apostrophe, it's going to be a row vector, but if I do put the apostrophe, this turns to column, a column vector. Thank you. All right. The question says, um, write an expression that refers to only the odd numbered element in a vector, regardless of the length of the vector. Test your expression on vectors that have both an odd and even number of elements. Okay. Now let's say the vectors are like vector 1 is the vector 1, step of 4 to 20, and then vector 2 is 1 step 4 to I'll go to 25. No, I'll go to 29. Okay, yeah. Such that if I do vect1, we have 5 elements, and then vect2, we have 6, 7, 8. 8 elements. 8 is even. So we're going to test vect1 and vect2. Well, there is a function that helps us determine the length of a vector. The function length. If I do length of vect1, for instance, vect1, and I press enter, it tells me the number of elements that the function vect is. If I also go for length 2, I can determine that there are 8 elements. Now, I need to display only the odd numbered elements, meaning the first, third, fifth, seventh, ninth, etc. So in this case, for vector1, for instance, it has only 5 elements. So the first, the third, and the fifth element. How am I going to do that? I'll go, let's first clear all this. Let me just write this and vec2. So if I need to display only the odd numbered elements in vector1, I'll write vect1, open and close brackets here, and inside the bracket I'll do 1, 2, because I need to jump every second element, okay? So the first I'll jump step 2, and then I say length vect1, okay? And then press enter. It displays the first, the third, and the fifth element of vector1, okay? Maybe if we need to see that clearly, vect1 is, yeah, the first, which is 9, the third 9, the first is 1, the third 9, the fifth is 17. So if I need vect2 is 1, this, if I need to display only the odd numbered, I'll go vect2, et voilà, vect2 in the bracket, and then I do 1 to 2 to length vect2, and then press enter. You see, I display only the first 1, the third 9, the fifth 17, the seventh 25. Alternatively, I can use the end function. Okay, let me clear all this out. If I do, okay, I have vect1, vect2. So now if I use the end function, it will be like vect1 and end like this. And if I press enter, it displays the first, the third, and the fifth. Similarly, for vect2, press enter, it shows also the first, the third, the fifth, and the seventh. Thank you. Well, the question says create a vector variable vec. It can have any length. Then write assignment statement that will store the first half of the vector in one variable and the second half in another. Make sure that your assignment statements are general and work whether vec has an even or odd number of elements. Alright, let's first understand the question, and for sake of understanding the question, I'm going to create a vector called vect even. Okay, just to say this vector will have an even number of elements. So I'm going to say line space. I can use the line space and say 3 for the first element and 17 for the last element, and I want even elements, so I can press 6 there, and I have even elements stored in vec even. So now let's say these are the elements. Okay, let me just, okay, these are the elements that I need to, so I need to separate this into two. Okay, first into two half. So this one for vector, let's say vector 1, and this one stored in vector 2. Okay, to do that, first let me show something. If I say vec equal to, let's say vec even, and I say 1 for instance, this will store in the first element of vector even into vector vec into a variable vec. Okay, it stores in that first element of vector even in the variable name vec. So if I do something like, I can do for any number. Let's say if I say like 4 for instance, it will store in the fourth element, and I can also do something like from 1 to the end. Okay, it will store in all the elements into vector vec, and so forth. Them some indexing manipulation here, but this is not the point. Um, Let me write what we had here. We still have it in a in the command window in the workspace. So vect event. This was vect event. So I'm creating a vector. Let's say vec one to say the first half. Okay, the first half of this vector. So this will be vec even from 1 to half. So I'm gonna say to end, okay, divided by 2, because end will take the end, tells the number of elements, so divided by 2 will give me the half. So if I press enter, I have the first half the the vector, so from 3 to 8.6 here. Then if I need the other half, I will just say, okay, let's say vec2 is the other half. This will be vec even, um, and then I'll take end over 2. Okay, but this one is already in in the first half of a vector, so it is the 8.6 position, so I don't need it. I want to take immediately 11.4, so I must plus by 1 here. I'll plus 1 there. So all this, if I want to do some space, all this uh is like for the first element. So but I want to now to go through the other elements, so I can just put some space there. Say okay, from here to the end, and then I close. Voila! Again, press enter. Okay, I got the second half of elements of vector even. It works like that, but we will not always be lucky to have even elements, even number of elements. But we might have something like a vector which has odd number of elements. In that situation, what can we do? Let me create a vector called vect odd, where I will store in odd number of elements. So I say line space. Create a line space. I can say that the first number is 3 and the last is 17, and I want 7 elements. Okay. In this situation, I will do this. You can see that half of the elements is okay. Let me first write the elements. They are like uh let's say 3 and 5.3, and then 7 points. I just want to write one decimal, and then 10, and then 12, and then 14.6. I just want to write one decimal because of space. Okay, so now if I want half of 1, 2, 3, 4, 5, 6, oh, there are more. 7. Okay, there's 17 there. Well, because of space, I'm going to let me erase this. I need to present all the elements. Okay, up to 17 there. So these elements are like um 3, 5.3, 7.6, and then 10, and then 12.3, and then 14.6, and 14, that's 14, and then 17. Okay, so now if I count my element here, that's 7, and the first half we'll split this one into 2. So it's gonna take like, but remember, uh, the half will be the 3.5 position. But 3.5 position does not really exist because the position must be integer, positive integers. So what I'm going to do, I am going to just take the first 4 here for the first vector, and then I want to take also this last 4 here, including the middle one, for the other vector also. So so I have like the quality, like to make them exactly half. So how am I gonna do that? I go, let's say vec1 will be equal to vec odd, and I say from 1 to if I say from 1 to end over 2, end over 2 will generate an odd number. So now to avoid that, I can use the round function which will round to the nearest integer. So this will round it to nearest integer, and then if I do that, and then I press enter, this takes the first 4 elements here from 3 to 10. Now I want to take also the other half, meaning the last 4 from 10, starting from 10 to 17. Then I'll say, okay, vec2 will be equal to vec odd. Then this time I'm not going to use the round function. I am going to use if I want that, I can do okay, let's first see if I use the round function, what would happen. If I use the round function, it's going to be round end over 2, okay, which will give me that middle number I want to the end. Okay, if I press enter, yes, it works. But now I can have 2 half. But is it gonna work also for the even number? Okay, let's see if this will work with the even number. Let's say I'm gonna use my this time I'm gonna use vect2. Let's see, I'm gonna use this formulation for vec2. Let's see, for vec2, for instance, for vec even, I mean vec1 equal to vec even. Remember, if I do that, I have the first 3 elements. Now let's do vec2 then, which with even number then, and then I press enter. Then this gives me not the last 3, but it takes also it gives me the last 4. Now the 2 vectors are not actually they're not equal in numbers, so they're not halves of each other. So there's something that we can do here. What then? Okay, I can say this is a better formulation so far. What is it? Vect one and round, where I use the round function. But previously, to find the other number, to avoid repeating the number, I did plus 1 here. So I can do something similar. I can plus 1 to vec2 to the last, like here, to vec2, I can say I can plus 1 here, but I need to change this round to fix. Okay, let's check with odd if it will generate the same answer. If I do that, okay, no, let's first let okay, for sake of illustration, I'm gonna start with vec1, vec1 odd. Let's see vec1 odd, vec1 odd. Or first, let me just display that was the odd element, and then vec1 odd, we find this full, and then if I do vec2 odd, and then I change the round function to fixed function, because the fixed function fixed the precision toward the 0, and I plus the 1 here. I want to put another parenthesis here, fixed, and then here I plus 1, and then close there. I still have the other half. Now let's check it for the even number then, the vector which has even number. I'm gonna use the same formulation now. Let's say, let me first display the vect even. This has even amount of elements, and then let's use this formulation. I'm gonna use now. Let me change the vector. It's vect even, and then press enter. It works. Now let's find vec2 using the same formulation with the fixed, and then if I do that, even, and then press enter, et voila. Now I have this. Now I can check with any vector. I'm gonna use now, start answering the question. If I use the vector vec, for instance, I say vector vec equal to do 4 to 5 to 61. I don't even care whether it's even or odd number. Then I can just use vec1 and just go back like this. Vec1 equal to, I'm gonna change this to vec, and this will take the first half, and then if I want to do vec2, I just want to change here, use the upper arrow to go back to the previous command line, and then press enter. Yes, it gives me the last half. So let me just check the length of the vector. So length of vec, and then it was an odd, an even. It has an even number of elements. I want something that will give me an odd number of elements. Let's say now vec2, for instance, equal to line space, line space, let's say 3 comma, okay, I used too much, let's say 7 comma 64, and then I want how many elements? Let's say 11 elements now. Okay, gives me this vector, and then if I want to check it, I'm going to use this formulation. For I want to take of the first half of the element of vec2. If I do that, okay, I need to change vec2 here by vec2. Yeah, vec2. Okay, now it will correct. Now let's see vect2 then, if it will work. Yes, it must be working. And then here vec2 here, and then press enter. Voila, I have the other half. So I hope you enjoy it. It was a bit longer, but I did all this just for sake of illustration. Thank you. All right. Okay, we are asked. The question says, using colon operators for the rows, create the matrix 7, 6, 5, 3, 5, 7. Okay, to do that, because we can see that in the first row, we can see that elements are such as okay 7, 6, 5, and then we can see that this decreases by 1 unit, so meaning the constant difference here just -1. So we're going to take this -1 here for our constants, our steps. Okay, so in the matrix, I'm gonna write here 7 colon -1 colon and 5. Okay, let's first test it. So 7 -1 and then 5. We can see we can form that row, and for the other one 3, the other row 3, 5, 7, we can see that the constant difference here is 2, so we can put 2 in the middle here. If I start by 3 and then 2 and then to 7 and then press enter, you see we have the row 3, 5, 7. Then this is what I can put here in to construct the matrix. I'm going to say 7 to -1 to 5, semicolon 3 to 2 to 2, okay, step 2 to 7, and then press enter. Then we have the requested matrix. Thank you. Well, the question says generate a 2 by 3 matrix of random. Okay, first one, real numbers. So each in the range from 0 to 1. So if you need to generate that matrix, you can just use the range, because the range function generates real numbers between from 0 to 1. So I can just do 2 by 3, because here, okay, it's something like let me use the red color. So range, it's something like this. If you put in the brackets, that's going to be number of row, and that's number of column. Okay, so in this situation, just going to say range 2, 3, and then press like that. It will generate a matrix between 2 and 3, between 0 and 1, a 2 by 3 matrix between 0 and 1. Yeah, that's actually what I meant. Thank you. So it generates something like that. Okay, no problem. Let's clear this out. So if you want to generate now a real number in range from 0 to 10, in this situation we can still do range 2 by 3, because 2 row 3 column, multiply by 10, and this will generate a matrix, a 2 by 3 matrix from 0 to 10. You see, numbers won't be lower than 0, neither more than 10. See, that's how it works. So okay, and then if I want to generate integers now, integers each in the range from 5 to 20, this is given by I'll call it formula. Let's say this is the formula. I'll say randy open bracket, and then we use the square bracket to say, okay, fine, this is the lowest the minimum value, so I'm gonna say x min, and then there I can put x max, and then we close, and then there row and column. So to generate, I'm gonna say randy square brackets, and the smallest number is 5, the highest is 20, and then I can start putting, I put comma, and then the how many rows, 2 rows and 3 columns, and when we press enter, we have this matrix. So yeah, we can see that it can only generate that sort of matrix. Thank you. And you can just press CLC to clear the command window. Thank you. What the question says, create a variable rows, which is a random integer in the range 1 to 5. Create a variable cols, which is a random integer in the range 1 to 5. Create a matrix of all zeros, which with the dimensions given by the values of rows and cols. All right, let's say rows will be uh, a will contain a random integer in the range from 1 to 5. So I can just say randy. Okay, first of all, before I do that, I can do this randy 5. This will generate only integers in the range 1 to 5. If I do that, you see, I will generate only integers. Okay, those ones. If I clear this, you see, I do that, it can only generate. Okay, so the formula might be something like um, if we do rent, let's see, randy, I mean, randy x n. Okay, how can I say this? Xn, it will generate only values of which are less than or equal to xn, including xn itself. So if this is 5, for instance, like in this case, it can produce its values either 1 or 2 or 3 or 4 or 5 itself. So in this case, okay, let's just clear this. I can say, okay, rows equal to randy 5. Okay, cols equal to randy 5 also. And then the question says create a matrix of all zeros with the dimensions given by the value of rows and columns. Okay, first let's talk about the zero, the matrix consisting of zeros. Okay, there's a matrix. If you say 0, zeros, like I say something like 2 3, and this will generate a 2 by 3 matrix consisting of zeros. Okay, so it is given by okay, zeros, and then row, column. Okay, it gives me R row and C column. Now if I need to generate that matrix, I can just say 0. Okay, first maybe just let's say type in a row and see how many elements were there, and then cols, and then okay, let's just clear this. We had rows, and then um and then cols, and then we can now do zeros of rows and cols, and then when we press enter, it gives us this matrix. You can see exactly there are 3 rows here, 1 2 3, and 2 columns, 1 2. Thank you. Okay. The question says find an efficient way to generate the following matrix met. Okay. So because we can see that in the first row, numbers are like if here in this first row we have 7, 8, 9, 10. We can see that these numbers have a constant difference of 1. So we can just write we could write 7 colon step 1 and step 10, but by default Matlab accepts 7 to 10 like this. It will take the one inclusively. Let's test it first. If we can do 7, 1 and 10 like this, it will work. Or we can just do 7 colon and then 10. It will still give us 7, 8, 9, 10. And then now the last row we can see it's 12, 12, 10, 8, 6. We can notice that there is a constant difference of -2. Okay, it's decreasing by 2. So in this situation, we can just do something like here we can do 12 semicolon -2 because the step is decreasing. And then we press enter. We have the entire second column. So in short, let me clear this CLC to clear the command window. I can say met the function met equal to the matrix met equal to square bracket 7 colon and then 10 semicolon, and then I can say 12 to colon -2, and then the step of -2 and 6 there, and then when we press enter we reproduce the matrix. Now the question says also then give the expression that will for the matrix met. First, refer to the element in the first row, third column. Okay. Let me clean this. Okay, this is the matrix. That's the matrix that we have. We have the matrix 7, 8, 9, 10, and then 12, 10, 8, 6. Okay. First row is this one, and then refer to the element in the first row and third column. Third column is 1, 2, 3. So this one. So actually, we're going to look at the number at the intersection. Okay, we're looking at this number. Intersection is here, where we have 9 there. So how can we get that number? We can just say, okay, met in the bracket like this. First row 1, and then third column is 3, and then we press enter, and then we got 9. So let me just emphasize here. This is row 1, uh, row 1, row. Oops, I don't write row like that. Let's say row 1, and then row 2, and this is column 1, column 1, column 2, and column 3, and column 4. So first row right there, and the second column here. And then they said also refer to the entire second row. The entire second row, the second row is here, 12, 10, 8, 6. So entire second row, I'm gonna say met, put in the bracket like that, and then the row is 2, and entire second row I can just say comma, and I can just leave a column like that, and then press enter. It takes all the second row. Okay, or I can do yeah, actually this is what I can do. Thanks. Refer to the first 2 column. The first 2 column I can just write met, and in the bracket like this. First 2 column, column 1 and column 2. I'm gonna say from we can do something like met. Met. Um, I can put the semi. Um, this one. I can put the semicolon here. And then say uh, 1, 1 to 2, and press enter. Voila, we have it. Okay. Um, or alternatively, we can also, can we do something else? Yes, we can. Because of space, okay, let me clear all this. Mets here. I can also do, I can do like this as I did, semicolon, and then 1 to 2 to take. The semicolon will take means what? It means it will take these rows, okay? It will take row 1 and row 2 all the way through. But now because I only need the first two columns, I only need um, this. In this question, let's say I only need this column. This one and that one. I'm gonna say okay from row 1, from column 1 to column 2. I mean, and then when you press enter, it generates. I can also do something like this. If I do this and then I said okay, from 1, okay, no, I never mind. I just gotta stop here. Thank you. Well, the question says, create a matrix variable, mymet, which stores the following mymet 258753. Using this matrix, find a simple expression that will transform the matrix into each of the following. All right. Okay, let's first create the matrix. We need to create this matrix to mymet. We can see that in the first line, let's test the first line starts from 2, and then the steps is 3, and the last number is 8. So we can reproduce the first line. The second line also decreasing by 2. So we're going to, excuse me, minus 2, um, minus 2 to 3, and then we press enter. We can see that we can create that matrix. I mean, that's a row. So we can now create the matrix mymet and say mymet equal to restoring 2 to 8, semicolon, 2 to 8, but the step up is 3, 8 there, semicolon, and then 7, the step is negative 2, to 3, and then we press enter. We have the matrix mymet. Okay, we're done testing. Let's first clear this, and we can type in mymet, and I press enter. We have the matrix. Okay, now the intention is to reproduce this matrix, this one, because the question say we need to find the expression that will transform the matrix that we have here into this matrix. Okay, what do we notice? We have noticed that in this matrix, the lines become the column, because here we have 258, and that 258 is now a column. Same also, this side we have 753, and then the 7 times 3 is becomes also the column. So this action is called transpose. Okay, we transpose, and then the symbol we use is the apostrophe symbol, as you can see here. We use the apostrophe to transform the matrix. So I can just write my met, and then with the apostrophe symbol like that, press enter, and then I have this matrix to this very matrix. I have it if I do that. Thank you. Um, the second question wants us to create this matrix, not this one. And then let's first say my math. We need to transform my math into this matrix here. So how can we do that? We can notice that the function, the matrix, my math is reshaped to this matrix because we can see we have it's two. Remember, Matlab reads, uh, how can I say, vertically like that, columns. So 2, 7, 5, 5, 8, 3 doesn't go like this horizontally but vertically. 2, 7, 5, 5, 8, 3, and then we can see this is 2 and then 7 and then 5 there, and then this is they became like a column, and then 5 in that column, 8, 3. So we can change the dimension of the matrix by, we can see that this dimension changed to a 3 by 2 rather than 2 by 3. So we can use the function called the function reshape. Okay, here is the function reshape. I'm gonna say, okay, let's say it's here. Well, we can use the function reshape, okay, to reshape this, to reshape my math. So to do that, I'm gonna say reshape in the bracket, my math, and then there I can put the number of column I want. So now instead of two, start with the row first. Instead of 2 rows, I'm gonna say 3 rows because we have like we have now 3 rows, so 1, 2, and 3, and 2 column 1, 2. So I'm gonna change. I'm gonna say, okay, there instead of 3 2 rows, I'm gonna say 3 rows now, and then instead of 3 column, now the column are changed to 2 columns. So I'm gonna say like that. So when I press enter, I reproduce the same matrix now. You can see that this matrix is the same as that one. So thank you. Okay, I'm gonna say my math again. Now this time we need this matrix. Okay, let's just move it a little bit here. We want to reproduce this matrix. Okay, what do we notice when I see this matrix and that one, the matrix on the left and the matrix on the right? Okay, we can notice that the matrix on the right is simply the matrix on the left but swapped around, flipped. We can see that the column 8-3, this column 8-3. So this column 8-3 is now swapped, becomes the first column, and the column 5-5, of course, will stay in the middle because there are only 3 columns, and 2-7 is the last now. So we can see now this was column 3, and this is column 2, and this column 1 now. So the matrix is a little bit, not a little bit, it is flipped around from left to right. So we can use the function flip. Okay, move a little bit here. The function flip. What does this function do? This function flips the matrix, okay, from left to right. Example, you see here, the matrix 1, 4, 2, 5, 3, 6 is now 3, 6 become the first line, 2, 5 still in the middle, and 1, 4, 1, 4 the last one. Now we can just do a flip left to right, so then bracket, and then my math, and then press enter. Voila, we have flipped the matrix. Thank you. Okay, well, this time we need to create this matrix that you can see on the right. Okay, so let's first the matrix was my math. If I say this, now we need to transform this matrix to match this matrix here, first we ask ourselves what do we notice. Okay, any idea? Come on, guys, anything? Okay, what I see is that this matrix, I can see that the first line, 258, is rotate, okay, and becomes the first column by starting from 8 down to 2. So it becomes like it's the same matrix as the same. I mean, it has the same element as this one. Compared to 258, and then we have 852, but in the first column. Similarly, the row 753 turns to becomes a column, the column 357, starting from 3. So it's kind of rotates, the line rotates 90 degrees. Um, uh, so 90 degrees to the left. So we can say rot, we can use the function that do that is the function, sorry, the Matlab function that does this is the function rotate. I'll put it here. The function, okay, I'll put it here. The function rotates, it rotates 90 degrees. It rotates the array, rotates array 90 degrees. So to do that, I can just say rot 90, and then there say my met, and then press enter. You see, we have reproduced the same matrix as this. Thank you. Well, now we have this matrix, so let's just make it a little bigger. We need to reproduce this, transform the matrix on the left to looks like the matrix on the right. Okay, what do we notice here? Do you notice anything? Yeah, I can notice that it's the same matrix but repeated twice now. So it's 258 and 258, 753 and 753. So to do that, we won't say my met times 2. No, we won't do that, because if we do that, we just times the elements by 2. So we had my met. What we can do, we can say, okay, we can just open a square bracket and then say my met, and then my met there also. So my met there also. Um, when we press enter, and then okay, misspelling. So thank you, Matlab. Oh, that has a mistake. Misspelling. I say my a met. Okay, it's supposed to be my met. Thank you, Matlab, for reminding me. And if I press enter, it just doubles the element by itself. So 258 becomes doubles this row. 258 and 258 there. 753, 753 there also. Thank you. Et ben voilà. Thank you very much. Well, the question says create a 4 by 2 matrix of all zeros and store it in a variable. Then replace the second row in the matrix with a 3 and a 6. Alright, we are asked to create this matrix. When they say a 4 by 2, a 4 by 2 matrix is simply means 4 rows with a matrix with 4 rows and 2 columns. Okay, columns. Now, meaning we are asked to create this matrix 0 0 0 0 0 0 0 0. So 1 2 3 4. Yeah, and then the columns are 1 and 2, correct. Now the question asks us to transform this matrix into into this matrix 0, 0, the first row. The second row, the question says it must be changed to. Okay, let me do this so to not confuse with for the second row, the question says we need to change the element of the second row by 3 and 6, so that's going to be 3 and 6. And then the third row will be C0, 0, fourth row C0, 0. So that's what we need to do. Okay. To do that, there is a function called zero function that we're going to use to create. It's the function I'm going to use to create a matrix consisting of zeros. So you can see I can use this notation 0 open brackets m stand for the number of m and n stand for the dimension of the matrix, so the number of rows and columns respectively. So in this situation, I can just say let's first I can say my matrix equal to zeros 4 by 2. Okay, press enter. Voila, we have the matrix. Now I need to change the matrix into this matrix. Voila. So how can I do that? I can just say my met and then open bracket and close bracket, and then select the second row, and then I'm gonna put the column operation to say all the way through, meaning all the way through the second row, and then equate it to a matrix to a vector 3, 6. Okay, this will replace the elements that are in the second row by the element 3 and 6. If I press enter, voila, we have 3 and 6 there, and we also have it there. So we can say the question is answered. Thank you. Well, the question says create a vector x which consists of 20 equally spaced points in the range from -pi to pi, positive pi. Now create a y vector that is sign x. Okay. There is a function called line space. As you can see here. The line space is a linearly spaced vector. We are going to do this one. Use this description. It says that line space generates. Okay, that's not good. I'm gonna say I'm gonna use this description. Voila. Okay, line space generates endpoints between x1 and x2 for n1. Line space returns x2 only. Okay, but here n can be okay, endpoints here. So because I need 20 equally spaced points, I'm gonna say okay, let's say x equal to line space -pi to pi, and I want 20 equally spaced point, and I press enter, and voila, I have the matrix, the vector. And then if I need to calculate now sine of x, I can just do now to calculate y, I'm going to say y equal to sine x. If I want to calculate the angle in the value of the angle in radians, it's going to be sine x, and if we press enter, we have the result. And if you want it in radians, okay, let's say this was x. No, seriously, x was here. If I want the answer in degrees, then I will say y equal to sine d. and then X there, and then press enter. Voila, we have the answers. Thank you. Well, the question says create a 4 by 6 matrix of random integers, each in the range from -5 to 5. Store it in a variable. Create another matrix that stores for each element the absolute value of the corresponding element in the original matrix. Okay, to generate a matrix of random integers, we can use the function randy. This function, randy, let's say, okay, voila, the function randy. Randy stands for random integers and stuff like that, and the what I call the expression that suits this question is this expression r equal to randy round bracket, and inside the round bracket we have the square bracket. I min stand for the minimum integer, and I max will stand for the maximum integers, and then we can place in the dimensions still in the round bracket. Okay, to do that, let's first test it. If I do randy round bracket and then I say something like that, I want to generate a matrix from 8 to 30, for instance. Okay, between generating matrix of elements which are at least 8, at most 30, and then I need to specify the dimension. You can say like a 4 by 6, for instance. If I press enter, it will generate. Okay, all the numbers here must be at least 8 and at most 30. So 30 is the highest number here, and then the smallest cannot be less than 8. Okay, so now let's answer the question. We can say, okay, say I come choose my met, and that's my met equal to randy, random integer, and then round bracket, and then square bracket there. There I can place my -5 to 5, the minimum and maximum integers, and then I can now place in the dimensions of the matrix, and the question wants us to create a 4 by 6 matrix. And when we press enter, voila, we have it. So we have the required matrix. And then the question says also create another matrix that stores for each element the absolute value of the corresponding element. Okay, I call this one my mat2, and then it will store in the absolute value. To do that, there is a function called um, apps. What is the function apps? Okay, I'm gonna place it here. The function apps is stands for the absolute value. Okay, and the absolute value turns all the negative to positive and keeps the positive number. So if I say my mat2 equal to, I can say apps my mat, and then when I press enter, and then voila, it's the same matrix. Then we only take the positive positive the elements, so the negative disappeared, and all of the other elements here are positive now. Thank you. Well, the question says create a 3 by 5 matrix of random real numbers. Delete the third row. Okay, let's say the 3 by 5 matrix is my met, and then I'm gonna use the rand operation to create the rand function to create random numbers, random real numbers. So I'll say 3 by 5, and then when we press enter, we have a 3 by 5 matrix of real numbers. Now we need to delete the third row, but before, let's talk about how to select the third row. I can just do my met like this. If I need to display the third row, I can use my math and then the column operator, press enter. This will display the third row. You can see that this is the same as that. Now, if I need to get rid of this third row to take it away, I'm not gonna just use the backspace, but we need to apply this expression. We're gonna do my mates, and then we do the third row, and all the third row. The current operator will take the whole line, the whole row, third row, and then we're going to equate it to a empty vector like that in the square brackets, nothing. And when you press enter, we have now the matrix, the 3 by 5 matrix expressed into changed now, deleted. Why the third row is deleted, so we express it in terms of 2 by 5 matrix. Thank you.